Non-determinism is one of the biggest challenges facing people who are switching to using AI assistants for software development. And what I noticed is that there are some various attitudes towards non-determinism. One of them is just ignoring the problem and asking the models to generate code. This can lead very quickly to issues like code that is generated is not that good, or we forget previous decisions and so on. Other people realize that it's an issue and they try to force assistants to be more deterministic. And while this is possible due to their architecture, it is virtually impossible to make it so that you get interesting, useful results, and at the same time you get deterministic results. This is just the nature of these models. So because of this, I'm introducing a quadrant that discusses the different areas for determinism, non-determinism, static and dynamic content or domains, and how we can move from each other and how this helps us in software development. Welcome back to Think Design Work Smart. I'm Alex Bolbak and I'm coming at you from the Mosaic Work Studios, and today I want to talk about this quadrant. First, we have two axes. One is deterministic and non-deterministic, and the other one is static versus dynamic. And we have static and deterministic quadrant, which an example there is documentation. It can be a static website. It can be a wiki, which is fundamentally static. I mean, you edit the pages and they are there, but once they are there, they kind of are. So it's like articles in a knowledge base. You have dynamic and deterministic, and the biggest category here is code, programs that we write, which tend to be dynamic, but also deterministic. For specific inputs, we want specific outputs, but the output is determined by the input. It's not like if you go to an URL, you get the same thing, or if you go to a document, you get the same value. They change based on the inputs that you provide. Or dynamic websites, for example, or dynamic parts of websites. Then we have static and non-deterministic. This is an interesting category, and I thought about it for a while, and I realized that this is where random data lives in. When you generate the random data, it's not deterministic, but once generated, it is random, but is deterministic. In other words, the process of rolling the dice is non-deterministic, but once you rolled the dice, the output of the dice is static. So it's a 6. And then we have dynamic and non-deterministic, which is GenAI. What I mean by this is if you pass in the same inputs, you might get different outputs from GenAI, depending on the temperature parameter that you pass in, but also on other factors, because they are fundamentally non-deterministic. And they are dynamic because for different inputs, you get different outputs. So now what is the relationship between those? Because we are using all these mostly 3 quadrants in code. Random data, not that interesting. You can generate random data with programs, and that's fine, but usually not that interesting. what interests us more for the process of development is the relationship between GenAI and code, GenAI and documentation, code and documentation, documentation and GenAI. So we can use GenAI to generate code, but you see that code is dynamic. So we are only moving on one axis. We're moving from non-deterministic to deterministic. But we can also use GenAI to generate static and deterministic, that is documentation, and then use the documentation with GenAI to inform GenAI to generate other things like programs or documentation. Now, interestingly enough, because programs are dynamic, we can use programs to generate programs. We can use programs to generate documentation. But we kind of knew that. So now what is the interesting part? The interesting part is that we can switch from the non-deterministic side to the deterministic side in two ways. On the line, we can use GenAI to generate code, or on the diagonal, we can use GenAI to generate documentation. And what I would argue is that the cycle that works best for based on the limitations of GenAI and based on what we require from programs is to use GenAI to generate documentation, which we then feed into GenAI to generate code, and we kind of move through this cycle as we progress. And this is one of the fundamental practices that I believe help a lot, and that I've seen in practice help a lot with using GenAI in order to generate code that is correct, that does what it's supposed to do, and that also fits what exists before. And then we may ask what type of documentation, what type of code. There are certain documentation types that are easy to feed into GenAI, and those are mostly text-based. And I'm talking diagrams as code, like PlantUML, Mermaid, Structurizer, whatever you use. Textual documents, and it can be dog, but honestly I prefer Markdown. And other kinds of Markdown formats. For example, I created a specific Markdown format to encode story maps, because I feel the story maps are particularly useful for larger projects. And there was no format like this, so I created a format and a tool that can help us manage story maps and feed them into GenAI. Then we have more structured documents like Gherkin acceptance criteria, given, when, then, example, mapping and all that stuff. And those are again very useful, but those are more constrained, still static, more constrained. And then we have architecture decision records, which document the types of architectural decisions that we made for this particular product. We could have, in addition to that, I mentioned architectural diagrams, really useful. And then if we switch to code, we have automated tests that serve as documentation for the code. And those are particularly useful because these are more constrained, and also they need to compile, which makes them more precise. And with this, you have, therefore, various types of documentation. Now, what I think is missing here is a representation of the domain model of the application. But for that, I feel that we might need something more interesting, like a RAG connection with an ontology that defines our domain model. But that's for the future. Now, the only thing is I have no idea how to name this quadrant, so I welcome in the comments, give me ideas for how to name it. And if this was useful, let us know in the comments and ask some more questions if you have some things you want to discuss more and to learn about. Also, don't forget, we teach all of these things at our courses on AI-powered software engineering, AI-powered application engineering, and AI-enhanced architecting microservices, where we go into all the details of how to use and we practice all these techniques. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.